Hello everyone, welcome to my course on Discrete Mathematics. I am Professor Anand Paul, an Associate Professor from the School of Computer Science and Engineering, Gyeongbuk National University, South Korea. I have been doing this lecture for more than 7 years, and this is the first time I am taking my lecture into this online course. I am very much excited about this course because it's giving me a different environment and different challenges. And of course, you students would also have a similar expectations. So let's see how it goes on from here. So this lecture is just an introduction part for this course. So let me briefly give you some background of what is discrete mathematics and what we are going to cover in this course. Basically, at discrete mathematics, we don't have a range of or a variety of math. Unlike linear algebra or graph theory or calculus, a discrete mathematics in itself is not a variety of a math. Rather, it covers many different aspects of mathematical foundations, and these foundations are very essential for computer science engineers. That's why we have this course on discrete mathematics that covers many different topics, including logics proofs, graph theory, functions, sets, and even more on other aspects like probability. So these materials that we're going to cover in this course would help you in other courses that you're going to have in the future. For example, courses like data structures, algorithms, relational database theories, automata theory and formal languages, compiler design, number theory, and so on. Yes, in this course is a very key course for these foundations, and in this course we are going to see both theory and some practical discussion, which means that I'm going to solve various different problems as we go on with this course. What is discrete mathematics, or what is discrete in sense? Well, things that we have in nature, more often we call it as continuous one, whether it's a sound signal or even the visual signals that we have, it is a continuous signal. To be more precise and to be very clear about what is a discrete and what is a continuous event, you can think about an analog watch or analog clock. That is a kind of continuous one, whereas a digital clock, it can be referred as a discrete one. As we know that the clock moves between each and every minutes or seconds, it's going continuously. It's going from 1 to 2, 2 to 3, and so on. It has passing by from 1 to 2. Rather, in digits or digital clock, it goes from 1 directly to 2, then 3, and so on. It jumps, right? Well, that's where the discrete part comes in. So we can compare this with that of real numbers. They are kind of continuous one, because real number consists of all the integers as well as all the rational, irrational numbers. All those fractional numbers are part of a real number. So if you want to count the real numbers, it's kind of impossible. Because we have infinite number of values that you can come about between two particular numbers. Even, for example, between 0 and 1, you can think about many different fractions. Yes, the combination of these fractions can be contributing to this range from 0 to 1. In the same way, if you think about a discrete example, you can take an example of an integer numbers. Yes, they have 0, 1, 2, 3, and so on. Like, it can be a positive integer or a negative integer. In any case, we can call this as a discrete one, as that's a simple example to begin with what is a discrete and what is a continuous one. Later on you will be covering many different areas in which how these things come to life, in a sense that we are going to use many different areas, for example logics like Boolean logics, where we are going to use discrete logic. And moreover, when we jump on to even graph theory, you would find that how we are going to use a discrete values to represent various elements in a graph. Well, that's a brief introduction. Now the question is, why do we have this discrete mathematics? Why do we need this? Well, since we are in the so-called science and technology age, this era where we have a massive growth in the computer science field. So there are many things starting from the gates, the logic gates, which combined together can contribute to build a chip, and in fact the logical gates can also be used to build a computer in some sense. Yes, there are a lot of areas in computer science where we define things by means of individual steps or discrete events, or we try to quantize things. When there is a continuous events happening, we try to make it as discrete one. For example, the sound signal. If you have come across the signal processing, yes, the sound signal, if you want to process and analyze it, we convert that into a discrete one. We quantize their value. And of course, even the visual signal, the video signal processing, even there we convert the continuous signal into a discrete one. In fact, we have something called discrete cosine transform. Well, we don't want to go deep down on those topics now. Let me just give you some examples to show why we really need this discrete math. Well, since we talk about these individual steps and discrete events and quantizing values, zeros and one, for example, if you talk about binary events, yes, that's where we are moving on to a discrete era, where we try to manipulate things by means of discrete values. Basically, it doesn't, if you look back into discrete events and if you look back and see where does it all started, well, we don't really get to the starting point of these things, because many different mathematicians, physicians, even philosophers, they have contributed, right? The reasoning, the logical reasoning, where we try to switch between 1 and 0, 1 and 2, or choice of having either this or this itself as kind of a discrete choice. We don't have a continuous nature. Yes, it dates back long time ago. You can think about Aristotle or other philosophers that might come to your mind. Yes, but today this has been used in almost every areas of computer science and engineering. And at times we will later on see how some of the things that we are learning in this discrete mathematics is also used in other areas of engineering and other fields as well. So we are going to cover things like logics and graph theory in our course, sets and relations as well, but eventually these things are going to help us in artificial intelligence, compiler design, and so on, even cryptography. Yes, let's see how things would turn out as we proceed with different lectures from this course. I will give you the brief contents of this course. I like to separate into three different parts. Logics and proof. Yes, under logics and proof, so that's going to be the core foundations for this whole course. So I would like to say that please focus more on this logics and proofs, because unless you are thorough in this area, it's very hard to understand the remaining parts. Well, in logics and proofs, we would discuss about predicate logics, quantified statement. Yes, these are some of the very basic things that's again going to help you in other areas. Then we will see some logical arguments. We'll try to find certain logics to make some conclusions. We'll see many examples on that when we come across those logical arguments. And symbolic representation, we are going to have various symbolic representations as we go on from one topic to another. I will introduce various symbolic terms that would be used, and then we will dive on to this number theory, and most of them in this part of number theory you should have covered in your high school, I suppose. Then comes the induction and recursion. So in this part we will discuss briefly about the sequence, in other words sequential logics. When I say sequential logic, it's not about the sequential logics that you come across in electronic circuits. So in generally speaking about sequence, it's a mathematical sequence. You might have studied about geometric sequence and those things that are related to such sequence. How do we come up with a sequence, or how do we come up with a formula to formulate a sequence? Then comes the mathematical induction, where we are going to cover weak and strong induction. Again, even when we talk about this mathematical induction, still the things that you have studied in your quantified statement, predicate logics, are going to help you here. Finally, about this recursive thinking, we are going to see how recursion can be very useful in solving problems, complicated problems. Yes, in the future you will see how recursion, when you use the recursive functions, it's going to simplify your programming. And finally, about this discrete structures, where we come across the Boolean algebra, set theory, functions, relations, graphs, and trees. Well, that seems to be very short when I say these things in words, but these are in itself huge topics, but they are very useful foundations for us. Basically, like you're going to see how the sets, functions, and relations are related to one another, and later on we will see some algorithms in graph theory, and we are going to see how we can use these trees for various structures. Further on, as we move in, I like to briefly give you this part about the liar paradox. What do you think? Here is a statement. It states, this sentence is false. What do you think? Is this sentence false? If this sentence is false, what would be the result? Or if this sentence is true, then what would be the result? Can you see a paradox? Can you see a contradiction? So if this statement is false, if this is true, then the sentence is false. If the sentence is false, then you can't say it's true, right? Yeah, there we say there is a contradiction, and this is kind of a paradox that has been established, and it's most fondly called as a liar paradox. Yes, we are going to think more logically and see how these thinking can give us or give rise to some arguments, and these arguments, eventually are going to help us in making some conclusions. Yes, that conclusions is what we are going to talk about. And later on you will find that how these simple logical reasoning is going to help you in your programming. Moreover, how it's been helping many people in making their decisions in their profession. Yes, these skills are still used in many professions, including the detectives as well as cryptography as well as forensics. They are still using some of these logics to make a conclusion about their statement. Coming back to this course again, I would be closely following this book, Discrete Mathematics with Applications, the 4th edition by Susanna. This is quite good book, and we will follow most of our lectures based on this book, though I will give you more examples that are not in this book. But still, if you like to buy a book, I recommend this is one of the good books for discrete mathematics. But you can also refer to other books if you like, because the main idea here is to cover each and every concept. I want you to get the solid basis for each and every concept that we are dealing with. It's not about the book itself. Yes, at times I do refer different books and I do solve some problems by myself. So I am going to share with you as we progress through these lectures. I am going to share with you different problems, different statements that are not from this book. But still, if you want to focus or if you want to follow a book, this is one of the book that is strongly recommended. Here is some thoughts on the grading policy. As this is an online course, so in this online course we are going to have quizzes and homeworks. So quiz, they contribute to 20% of your grades. Homeworks contributes to 20% of your grades, and we are going to have 2 exam period. One is the midterm exam, then the final exam. These 2 are going to have 20% each. And then comes this participation and continuous evaluation. So yes, this is an online course. You are asked to see the video first, and after seeing the video, you would be given opportunity to share or discuss with your fellow students by online participation in the discussion forum, or you are also encouraged to ask me questions. Yes, we want more participation. Participation is not in terms of attendance itself. When I say attendance, attending online. It's about asking questions. It's about giving some suggestions as well. Yes, this will be continuously evaluated. That's a very important part of learning process. So then we have this online attendance, right? So we have this part, the so-called online courses. Unless you see these online lectures, your attendance will not be automatically given to you, which means that if you are not seeing all the online lectures, I am automatically going to reduce some grade from your grades. So each and every week we have at least 3 videos to watch, and after watching these videos, I will give you simple evaluation methods to just make sure you got the idea behind the concept. And basically I am planning to give at least 8 homeworks. So randomly at a constant interval you will be getting homeworks and quizzes to evaluate you. Yes, this is what I talked about, the course evaluation criteria. There's going to be 8 homeworks, 4 quizzes, 2 exams. So your attendance in the online lecture is very essential for your grades, because this is an online course, and I encourage you to participate, ask questions online. You'll be given a chance to ask many questions and take part in the discussion with your fellow participants. Yes, I also encourage collaborations, because you students are learning in the learning process. Of course, you can discuss with other students about your homeworks or about your exams and so on, but of course you are not going to write exams together. Generally speaking, you can still discuss with each other, but don't try to copy your friends' homeworks, or don't try to copy from other sources as well. You're welcome to work with other students on homeworks, but the write-up must be entirely your own. In other words, yes, plagiarism is also not encouraged here. And if you need any other assistance, you can always contact me. Always try to take some questions during the lecture. Well, did I fully understand all the parts that professor said? If not, why don't you raise the question? If you are having some questions, then probably some other students also have a similar questions, and I am here to help you out. So please ask some questions. And moreover, have you heard of this Flukerson Prize? Yes, it's an award given for the outstanding papers in discrete mathematics. Well, we are not targeting this Flukerson Prize, but I just want to give you this awareness that discrete mathematics is not just a field that's been ignored by the mathematicians. Even the American Mathematical Society is recognizing this field of math. Initially, I told you that, of course, discrete mathematics is not like calculus or linear algebra or graph theory, but it contributes a lot for the entire foundation of computer science engineers. It covers various areas that can help you with algorithms, that can help you with logics, which eventually help you in artificial intelligence and so on. Yes, there are a lot of areas this can be used. That's why the mathematical societies and the community is still recognizes this discrete mathematics is one of the precious areas, and they recognize this with those prizes. Well, we are now embarking on this path of discrete mathematics, and you are going to learn, you are going to master, you are going to take part, participate, you are going to see different applications of this. Yes, why not embark and try to benefit more fully from all the lectures that are given here. As I told you earlier, basically every week we are going to have at least 3 lectures, and after these lectures I will give you a brief questions just to evaluate whether you got the point, and later on, after a series of videos that you have been watching, I would be providing you some homeworks, some quizzes, and these are useful for the final evaluation. In the meantime, we will also have set some time for evaluating you with the exams. And as the whole process goes on, if you have any questions in between, you can always contact me. You can send me emails. You can, of course, apart from emails, we have this online platform where you can also participate and you can ask me questions. Yes, as we look forward to this course on discrete mathematics, I really encourage you all to have good time as we embark in this lecture. All the best and have fun. Enjoy this class. And again, once again, I welcome you all for this course on discrete mathematics. Yes, let's start this exciting journey together. Welcome and thank you.